So, Warren got the idea from an episode of Breaking Bad.
See, in my opinion, it's all about the quinic acid level.
My God, that is the best coffee I've ever tasted.
Or we'll use different methods of brewing coffee to see the effect on the pH and the concentration of chinic acid. The control variable of the lab would be the type of coffee, the amount of coffee that we're using, and the amount of water that we're using. The independent variables would be the methods of brewing and the initial water temperatures of each, since we're going to be testing the effects of the temperature on the water pH. The dependent variable is the coffee quality and the base of the pH, and the standard of comparison is the coffee machine.
Okay, so the chemistry behind this coffee experiment is that whenever the water heats up, it'll allow more solute to dissolve into it, which means there'll be like more coffee in the water whenever we filter it out. So it'll probably taste better with different brewing methods, so that's what we're testing.
Alright, so we're going to test our coffee lab using a Florent siphon, which Warren will explain later once we have it set up. And basically, in normal brewed coffee, there's this thing called quinic acid, which makes it taste like yucky and bitter. So with coffee that we use with the Florent siphon, it'll have less quinic acid, so it'll be more basic in its pH. So our hypothesis is that the coffee made with the Florent siphon will be less acidic because it'll have less quinic acid and it will taste better.
Warren Vu, Jonathan Contreras here, setting up a Florent siphon and make some delicious coffee. Warren, why don't you explain to us how the Florent siphon is
Alright, in this contraction, you see this water that's being boiled that sends all of the water vapor that condenses down into here. And once we turn this off, the pressure will decrease and the volume will decrease too, thanks to some gas law we don't remember.
Boyle's Law!
And then it will send all the coffee back into here, nice and black.
Okay, just the way I like it.
So now over to our gecko gang.
Okay, so we have successfully leashed Navaldo.
According to the Tro chapter about rate reactions, lizards are ectotherms, which means that their temperature relies on their surroundings. So if we were to pour cold water on him, the little muscles wouldn't be able to react as fast, so he would be immobilized basically. So we have our cold water, we have our leashed lizard.
Record him okay. So Navaldo is freaking out right now. This is our standard of comparison.
He's pretty sticky.
Yep. He has a lot of adhesive forces. You see, he's moving around a lot. Kind of. Now before we switch over to the coffee crew, we're gonna have a quick message from our sponsors.
Insurance companies rarely play fair and hand over a fair award. They must be hammered and hammered before they see the light. I'm Jim Adler, the Texas Hammer, and I get results.
Spokesperson for Jim Adler.
Can you prove that?
Just listen to this. I hammered and got a client $140,000 after she fractured her back and had a collapsed lung. The proof is in the money. Call me right now. It's hammer time. 713-777-4000. 713-777-4000.
Back to Tro Busters. So, after our failed experiment using a hot plate to heat this up, which took about 30 minutes for any action, we decided to use a Bunsen burner, which is working a little bit better. However, all it does is make the coffee moist. After turning off the Bunsen burner, we can see water being sucked up, but not coffee right now. So, mild success currently. Good enough.
Okay, so it was leaking a lot, so we decided to put some Teflon right here. See that white tape? Right there, and some duct tape to help secure all the gaps. And now water won't leak out, and we'll have good coffee.
So we got this nice new setup thanks to Jonathan here, who decided it was a great idea to stick a tube in there. And after some surgical tubing started to melt, we decided to Teflon and duct tape it, Tro Busters style.
Okay, so this tube is melting.
Dude, it's okay. It'll be fine.
Yeah, it's fine.
I don't know if the water can go through it anymore. Yeah, the water flow has stopped. So this test was a fail.
Alright, so since this decided to start to melt, we decided to replace it with a glass tubing thing. And we're hoping that'll work, but it seems like it is doing pretty well.
Oh, yo, it's working. Whoa! What the? I didn't even see that.
Anti-stirring rod.
Get the thermometer, guys.
Oh, yeah.
What are you doing? Are you kidding?
Wait, what happened? Bro!
Don't turn it off. Don't turn it off. Don't turn it off.
Well, all the water's gone
What
anyway.
happened?
No, you're supposed to like turn down the heat like just enough
So that it
so the water
sustains.
doesn't go back.
Oh, okay.
Don't stir it.
So now it's like
supposed to
in
stir it.
equilibrium, you know? Homeostasis. Let's go. Let's try
That
to.
baby's going up.
Let's go.
Alright, let's go.
Bro.
What temperature is it?
Focus. Okay. It's at like around,
It's still going up, hold up.
okay, like 65-ish.
You can see the coffee's trying to go up the tube.
Let me get that. Oh, you see it right there? It's like going up
And there's still water
and back
over
down.
here trying to go up the tube.
Okay.
But nothing's actually up here because it's in equilibrium. Science.
Boom. Now over to our gecko gang. Okay.
His breathing rate slowing down.
Should I just pour the whole thing?
Yeah, dude.
So, looks like his breathing rate slowed down tremendously.
He's like,
And he's
not
like
even
frozen.
breathing.
He's like barely moving. Oh my gosh, we're dragging him and he's barely moving. I guess it's working. Yeah. According to Tro, if we add warm water instead of cold water, then the reaction rates will increase and then the lizards will be like extra speedy. Now it's time to put warm water onto cannoli here. It's not too hot, it's just a little bit warm.
Oh, she's superhuman now. What?
Okay. So now she should be like extra jumpy. Let's see. We lift her off the ground. Will she freak out? No! Oh, there we go. There we go. She's freaking out. Yo, okay. So she's jumping around. She's jumping around. All right, now over to the coffee crew.
Well, it's at 1:30.
Okay, how much longer do we need?
We got a minute and 20 seconds left.
Oh, there it
Oh,
goes.
it's starting.
Oh, there it goes.
It's starting up. Let's go. Let's go. Meow.
Can it make it past the second?
Oh,
It made it past the second. Can it make it past the third? And
bro,
we're in.
no. Look at that. Beautiful.
Beautiful brown.
You have-
Beautiful brown gold.
Yes, all across that.
All across that.
It's not coming out the tube, is it?
Okay.
We got the pH sensor hooked up to the Logger Pro.
pH.
Boom. Let's test it.
All right. Let's see what this hoe be eating.
6.4, 6.5. Okay, that's our final answer. Boom.
Alright, so some of the setbacks that we encountered during the lab. We had a tube melt on us. So what we did to fix the tube melting is that we replaced it with Teflon and duct tape. Yeah, George, the hot plate wasn't hot enough and it would take too long for it to heat up the water. So we just switched that out with a Bunsen burner. The leaky surgical tubing, again, we replaced that with the Teflon and duct tape because it would leak halfway through. And the melting pipette halfway through the distillation melted on us so the water wouldn't go through.
Okay, so the results of this experiment. So the pH of the standard of comparison with the coffee maker was 5.5. The next was the pH of the cold brew coffee, which was 5.97, which is pretty close, but it's still acidic. And then the pH of the Florent siphon was a whopping 6.51, which is like pretty close to being basic, you know? So, yeah.
In this experiment, we tested different kinds of brewing methods and how they affect the pH of coffee. So first we did cold brew, which is just putting grounds and water into a beaker and then putting it in the fridge for 24 hours, and then using a regular coffee machine. And those were our standards of comparison. And the pH of those were around 5.5. And we compared that to using the Florent siphon, which is supposed to have less quinic acid, and the pH was higher, around 6.5. So we saw that there's less quinic acid in the coffee of the Florent siphon, making it more basic. And we learned about the scientific process, that it's not as smooth as it seems, and there's lots of bumps along the way. And the practical applications of this experiment would be opening your own coffee shop and using a Florent siphon to make really good coffee, like in Breaking Bad.
I'm Barack Obama, and I approve this message.